So let's take a look at another one. 2 to the x plus 4 is equal to 54. Let's see, on this one, I've got 2. 2 is a great number to work with. Lots of lots of powers that we have memorized on those, but I notice that 54 is not one of them. So I don't have common bases, and I can't force common bases either because 54 is not a power of 2. So I might be stuck, but let's go back and remember what we did with this problem right here. This is kind of the same problem, except maybe in this problem, this exponent is just not as difficult. But I can still turn it into a logarithmic equation and solve for x. So let's do that again. Now, I can still do that here even though the exponent is now a binomial, x plus 4, instead of just a monomial, a variable x. So let's turn this into log base 2, excuse me, of the number 54 is equal to the exponent x plus 4. Okay, so I've got this equation that I can solve, which I'm going to need a calculator here to figure out the value of that log. So I'm going to use the TI Inspire. We'll go to the scratch pad and let's just put in log base 2 of 54. And so I get 5.75. Let's call it 5.75, and we'll go ahead and use we're going to go ahead and use 2 digits. We'll round to two decimal places here, and we'll say that 5.75 is equal to x plus 4. And to solve, again, the nice thing is that from here down, from green down, it's just like an Algebra 1 equation. All the new stuff that we've been doing is just these first 2 steps up to the blue line. So we'll subtract 4, and I get that 1.75 equals x. But to write it in standard form with the x on the left side, I'll say x. And I'm going to put these 2 wavy lines. We're going to say x is approximately equal to 1.75. And the reason I said that it's approximately equal to with the 2 little wavy lines and not exactly equal to is because right here at 5.75, I rounded that answer. When I did log base 2 of 54 in the calculator, I didn't include all the decimal places, and even the calculator was rounding part of that. So I'm going to say it's approximately equal to let people know that I rounded that answer. But what that means is if I take this value and put it in here for x, then it's going to work out that 2 raised to the what ends up being 5.75 is 54. So let's try it again. Here you can pause this and work on it yourself for a second. I'm just going to get right into the solution. Again, we're going to notice that I've got a variable stuck in the exponent, and I can't get common bases because 14 is not a power of 3. But I can make this log base 3 of 14 is equal to x minus 2. And at this point, again, I'm going to need that calculator to do log base 3 of 14. So we'll say log base 3 of 14. And I get, let's call that 2.4 if I'm going to 2 decimal places. So we'll go back here and say that 2.4 is equal to x minus 2. And that is a really funky looking 2. Okay, that's better. And we'll just go ahead and add 2. And I'll get that x is approximately equal to, again, because I rounded, 4.4. Okay, so I mean, if you want, you can check that out in your calculator. Let's take this answer. That was lame. We're going to take this answer, and we're going to say that this, if I put it in here for x, should equal 14. So let's give it a shot. Let's take 4.4 and put it in for x, and let's do that in the calculator. This is going to be 3 raised to the power. I'll put in parentheses 4.4, take away 2. And let's see what that gets me. Oh, so close, 13.967, but I wanted 14. And that is close, but think for a second, why would I not get 14 exactly? And the reason being, think about it, maybe get an answer, is because of this right here. Okay, when I rounded. When I rounded that answer, that means that I'm no longer going to get something exact when I plug x back in to check. That's why we say it's approximately equal to. Well, here's another one. This one looks a little bit tougher though, right? Because if you notice the difference on this one is that now I have a variable right here in the other on the other number in their exponent. So that's kind of tough. But let's give it a shot anyway. Noticing that I still can't get common bases, let's just take a logarithm. And let's just follow the log right here. We're going to take log. Let's make this base 5 of the number 7 to the x. And that's equal to the exponent on the 5, which is x plus 3. Okay, so now it seems like, oh man, you're trying to make a step here to make it easier, but now I've got this thing, right? Now I've got a variable in that exponent. But if you remember back from learning target 10, now we know a property that makes that a lot easier to solve, being that if I have an exponent here, I can just bring it out front. So that's x times log base 5 of 7 is equal to x plus 3. Okay, so now if you notice, I mean, I've got a couple weird things going on here, but I want to take log base 5 of 7 and find that value. So we'll go back to the calculator. I'll clear the scratch pad out, and we'll go log base 5 of 7, and you get 1.21. So we'll call that 1.21, and we'll go back. And since this value is 1.21, remember how we write that. It's being multiplied by x, so anytime a number is being multiplied by a variable, we put that number, which is called the coefficient, out in front of the variable. Okay, you wouldn't say x times 1.21, you'd say 1.21x. And now when I solve this, again, it's just maybe a little bit more advanced Algebra 1 equation. We're going to move the x over, so we'll get rid of the x. And let's remember on the left side here what we're doing. We're taking 1.21 and we're subtracting x, and that's really like having a 1 in front of that x, so we're subtracting 1x. And if you want to, you can write it as 1x if you're having trouble seeing it, and you can also do it in the calculator if you're having trouble with those decimals. 1.21, take away 1, and you just get 0.21. So what we're going to say here is we've got 0.21x is equal to 3, and just simply to solve it, we'll divide both sides by 0.21. And 3 divided by 0.21. So back to the calculator. 3 divided by 0.21. And we get 14. Let's call it 14.29. Okay? But don't forget that we're going to say that is x is approximately equal to 14.29 because we did a fair amount of rounding in there. Okay? So just go back and take a look at the equation. These last few learning targets are all about how do I get the variable out of the exponent. And we have that happening once up here, twice, and then we have it happening again here. But now we have the tools to get the variable out of the exponent every time. And then come up with an answer to what seemed like a pretty difficult equation to begin with.